In this video lecture, I will explain permutations. So what is permutations? If we are given n distinct object and we want to arrange R of these objects in a line. So permutation, we also call it arrangement. Okay, so next is what is the formula for permutation? So there are three formulas for permutation. One by one I will discuss. So first one is NPR. So when we say there are n distinct objects and we want to arrange R of these in a line, then NPR is the formula. So this NPR will be the number of arrangements or permutation we can say. So that is n factorial upon n minus R factorial. So how we have got this formula? So for example, if I say I have n distinct object and R of these we want to arrange in a line. So then for first object, so there will be n ways, okay, of choosing the first object, and then for second object there will be n minus 1 ways, okay, for second object, and then for same way remaining, I mean n minus 2 will be there for n minus 2 for third object, and finally there will be n minus r plus 1 of choosing the rth object. So then with that, and then we are going to apply the product rule. So it will be n into n means the first there will be n ways of choosing the first object, n minus 1 for choosing the second object, n minus 2 ways for choosing the third object, and then n minus r plus 1 for choosing the rth object, and all that we are going to multiply, and then from this we will get this n factorial upon n minus r factorial. And permutation, we will represent it like npr, or we can also write p n comma r. Okay, so this is the first formula. We can say this is the first formula for permutation. So whenever we have n distinct object, we want to arrange r of these object in a line. So whenever we are talking about arrangement, we will go ahead with permutation. Now the next formula is Pn comma n, that is n factorial. So what is this? Pn comma n, or we can also say it npn. Okay, so npn is n factorial. So here this is when we want the arrangement of n distinct object, okay, taken all at a time. So n distinct object taken all at a time when I want, it will be npn or pnn, and that will be npn is nothing but n factorial. So first formula was npr, that was when I have n distinct object, I want to arrange r of these, okay, so then it is n factorial upon n minus r factorial. Second one, when I want to arrange n distinct object taken all at a time, then it will be npn, and that is nothing but n factorial. So this is the second one. Now the third formula is when if we want to find the number of permutation that can be formed from a collection of n object, means I have n object, and from n, n1 is of one type, n2 is of second type, n3 is of third type, and nk is of kth type, where if I add all this n1 plus n2 plus n3 plus nk, I get n. Okay, so when I want to find the permutation that can be formed from a collection of n object, and in n I have n1, n2, n3 up to nk, when I add all these I get n. Okay, then what will be the number of permutation? So then the number of permutation will be n factorial upon n1 factorial into n2 factorial into n3 factorial up to nk factorial. So this is the third formula I can say. So this is third one. First one was npr, that is n factorial upon n minus r factorial, and the second one was npn, that is n factorial. So this, when we have n object, in n we have n1, n2, n3, nk, and adding all this I get n, then this will be the formula for permutation. This is when n distinct object, and from n distinct object r we want to arrange in a line, then this formula, and this when I want arrangement of n objects taken all at a time, then n factorial, this formula we are going to apply. So these are the three formulas that you have to keep in mind in permutation. Now let's take some example. So first problem is how many different strings of length 4, okay, string of length 4. When I say different string of length 4, that means we are talking about distinct object. Okay, so no, different string of length 4 can be formed. This is not distinct object, this is R basically. Okay, using the letters of the word flower. Okay, here this is the word, and you can see here all the letters are different, F, L, O, W, E, R. So this is nothing but distinct. Okay, so from N we want to arrange 4, means from this letter we want to find how many different string of length 4. So this R is nothing but 4 and N is 6. So the first formula we are going to apply when we want to arrange R object from N distinct object. And why it is distinct? Because all the letters are different. So then first formula NPR we are going to apply, and N is equal to 6. There are 6 letters, 1, 2, 3, 4, 5, 6, and R is 4. So 6 factorial upon 6 minus 4 factorial. This formula we are going to apply, and 360 will be the answer. Now let's take another example. Find the number of permutations of the letters of the word success. Okay, now here we are not going to arrange our object from n distinct object. So here the number of permutation of the letters of the word success. You can see here this is not distinct. I have S. Okay, S has occurred 3 times. Okay, and then C has occurred twice, and then U once and E once. Okay, so this is not distinct. And the third formula, this one, when I have n object and n1 is of one type, n1 is of one type means S, we can say here. Here 3 S are there. So this is n1 is nothing but S, okay, 3. And then U, I can say only 1, so n2 is 1. And n3 is nothing but how many times C has occurred, so that is 2. And E is n4, that is 1. Now if I add all this, 3 plus 1 plus 2 plus 1, so it is 7. And here also you can see 1, 2, 3, 4, 5, 6, 7. So then this is how we are going to. So what will be the permutation? It will be total n is 7. 7 factorial upon 3 factorial into 1 factorial into 2 factorial into 1 factorial. Okay, so the same solution is explained here in success because it is not distinct. Okay, so third formula we are going to apply. There are 7 letters. Okay, and then 3 S, 2 are C, 1 each U and E, and N is the total number of letters, that is 7. N1 is how many times 3 has occurred, so 3, and 2 is 2, and 3 is 1, and N4 is 1. If I add all this, I get 7. So the required permutation will be n factorial upon n1 factorial into n2 factorial into n3 factorial into n4 factorial. So 3 factorial into 2 factorial into 1 factorial into 1 factorial. When I calculate this, we get 420 as answer. So this is this one, third formula we have applied. Now let's take few more examples. Here this question, we have to find the number of permutation of the letters of the word, this given word. Okay, so this is the word and we have to find the number of permutation. So number of permutation is simple, and here also see, you can see the A 4 times. Okay, and then S 1, 2, 3, and then 1 M 1 time, and U also 1 time, G also 1 time. So this is not distinct, definitely. So first formula we are not going to apply. Second one also we are not going to apply. We are going to apply third formula. So the number of permutation will be total number of letters are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 10 factorial, where we have 4 A's. So 4 A's, so 4 factorial. 3 S, so 3 factorial. 1 each M, A, N, M, U and G. So 1 factorial, 1 factorial into 1 factorial. If we calculate this, we get this value. So I hope you people know how to find n factorial. N factorial is nothing but n into n minus 1 factorial. So if I want to find 10 factorial, so it will be 10 into 9 factorial, and then 9 factorial will be 9 into 8 factorial. 8 factorial will be 8 into 7 factorial, like that. Okay. And then second part is what here, in how many ways of these all 4 A's are together. This is the second. First one, just finding the number of permutation. Okay, and the second one is, okay, so here we have to find how many of these all four A's are together. So all four A's are together means here there are four A's. So we will consider these four A's as a single letter. Okay, and then remaining three S, one M, one U and one G. Okay, so then 3 plus 1 plus 3, 4, 5 and 6, and these 4 A's will be considered as a single letter. So there will be 7 total number of letters will be 7 factorial. 4 A's are taken together, so it will be 1, and then 3 A's means 3 factorial, 1 M and 1 U and 1 G. So this will be the these many ways in which all 4 A's are together. Now the next part is how many of them begin with S. Okay. So how many of them begin with S? This is the word. Okay. Now here there are 10 letters. So if I say there are 10 positions, 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10. And if it has to begin with S means this is fixed. Okay. Now remaining 9 positions we have to fill. So then in that, okay, this already one S will come here. So remaining we have 4 A's. Okay. We have 4 A's. And then we had 3 A's basic 3 S basically. Now one is fixed. So remaining 2 S and then 1 each M, U and G. So then 9 factorial upon 2 factorial into 4 factorial into 1 factorial into 1 factorial into 1 factorial. So this will be the answer. So hope you have understood the concept of permutation. Thank you for watching.